So this is C++ in the browser. My name is Richard Bateman, and this is something that I have done a lot of. My last about 6 years of professional work has been primarily related to browser plugins in one way or another. And I am the author of FireBreath, which is a cross-platform framework for writing browser plugins. Now, when we talk about browser plugins, we'll talk a little more about the specific technologies that are available in a little bit, because that's part of the point of the presentation. We're mostly talking about, or at least up till recently, we've been mostly talking about ActiveX and NPAPI, and that's what most of my stuff has been. And basically, the way I got started is I got so fed up with the crappy interface that the C programmers were putting on our plugin interface when I was working for a company called Move Networks, that I just sort of pulled down the C++ code, figured out how to build it, and started playing with it to see if I could fix it. And pretty soon I figured out how I could update the interface so it would work on Chrome, because it didn't work on Chrome at the time. And then I realized that I could actually combine the two different installers that we had, one for ActiveX, one for Firefox, so that I would just have a single one that worked, a single plugin that worked on both. And then as I learned more and more about the technologies, I realized that I could create an abstraction that would make a single, I could write a single project and have it just work on both. I'm a little bit of a compulsive framework developer. Long term, my background is actually more in web technologies. I've been doing server-side and then more recently client-side web development a lot, but through primarily FireBreath and browser plugins, I've become somewhat of a C++ guy as well. So that's kind of my background. I work currently for a company called GradeCam, theoretically based out of California. When I started working there 4 years ago, I was the only developer, I was the only member of the company that was not in California, and I would fly out there periodically. We hired a couple more developers in California. They lasted a little while, then they went away, and then we hired a developer here in Utah, and then 2 more developers here in Utah, and then a support engineer here in Utah. And long story short is we have 1 developer in California and 5 people here in Utah. So I sort of just took over the development team, moved them to Utah, and all 4 of our developers are actually presenting at this conference. So we're having fun. GradeCam's a lot of fun. It's a great place to work. We build software that teachers use in classrooms in order to better teach. Kind of our core philosophy is kind of that just throwing more technology at things doesn't always solve the problem. So we try to find a balance between providing the new features that they need and allowing them to do the things that they've already been doing. And the core piece of that, this is relevant to the talk actually, core piece of that is a technology that uses a webcam on your computer to read bubble answer sheets. Either just read a score, a bubbled in score in the top corner, or to read a full multiple choice, sometimes number grids, a lot of different stuff. But you just print it out on your printer, whereas some of the other scanning technologies that you may have heard of require you to buy special sheets. These you just print out on your printer. They bubble them in. You stick it, hold it up in front of or stick it underneath a webcam. And we've also got an iOS and an Android app. It will just grade it, can transfer the grades directly into the gradebook. Saves teachers a lot of time. It's a lot of fun because when I talk to teachers, they're just so excited about it. And I really enjoy working at a place where I actually feel like I'm making a difference and helping, kind of make the world better. As opposed to everybody says that they're making the world better, it's nice to actually see it in something as clear as education. So, C++ in the browser. Why C++? The first rule that you all need to understand is you should never, ever, 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 ever do this unless there are no other choices. It's just not going to ever be really pretty. You can do a lot of really amazing things, and in a lot of cases you kind of you kind of end up feeling like, wow, it's that adrenaline rush where you realize that you just built a fully functional aircraft out of tin cans and paper clips. It's like, that's really incredible that you can do that, and it's really, really painful that you had to. But there are a lot of features that aren't available in the browser, even with HTML5 yet. When I started with this, the video tag didn't exist, the audio tag didn't exist, And even once they showed up, and even now actually, there are a lot of limitations to what you can do with those that you can do a little bit more with some sort of a plugin. WebGL did not exist when I started. It now exists. In a lot of ways, I see a lot of the things that we do with C++ in the browser as the precursor to developing those actual web technologies in the browser. You build it first in the whatever hacky way we have to do it here, and then if enough people start needing that, eventually the web browsers will catch up and maybe we won't have to do this as much. We don't do this because we hate web standards. In fact, ideally, you understand the web standards before you start doing this, because just hate to break this to anybody, if anybody here is really big on C++ and not so much on web standards, C++ is not generally done in the same way that web stuff is. Does that come as a shock to anyone? Good, okay. But C++ is one of the most portable programming languages available. I hear a lot of people talking about, oh, why would you learn C++? C++ is a dying language. Newsflash for anybody who thinks that way. As long as all of the languages that people currently use are written in C++, C++ will not go away. Java is written in C++, .NET is written in C++, most major programming languages are written in C++, or in C, which is, for the intents of this conversation, practically the same thing, even though it's not. So, when we're doing C++, in the browser, there's a few different options. I have NPAPI, ActiveX, EMScripten, which compiles to ASM.js, we'll talk about, Google Native Client, Google Native Messaging, and there are some other less obvious ones that we won't talk about unless you guys have questions. So, NPAPI. NPAPI stands for Netscape Plugin API, and this is the oldest browser plugin technology that I'm aware of. Originally, NPAPI was actually created as a way to interface Java with the browser. In fact, a little tidbit for those of you who may not know, the reason that JavaScript is called JavaScript, even though it has absolutely no relationship with Java whatsoever, is because JavaScript was created as a way of adding some scripting into the browser that could talk to the Java applets and such that they had there, which were initially generally tied into a plugin. So, the advantages of NPAPI: it allows native code to be run from the browser. There's very tight integration with JavaScript, and I'm sorry that it's hard to read these. It was just really hard to fit all of this in on the slide. It has fairly decent drawing support. It's kind of a longer topic that we're not going to go into too much. It's supported by Firefox, Opera, Safari, and it was supported by Chrome until April. About April 18th or something like that. I could find the exact date if you want, because it was fairly crucial to me when they dropped support for NPAPI. You can actually re-enable support for NPAPI in Chrome. It involves going to Chrome://flags and going and saying enable NPAPI, but in a few versions they're actually going to turn that off, and NPAPI will be totally gone from Chrome. I could probably do an hour rant on that as well. I won't. It's very well known. Flash was written in NPAPI. Silverlight, NPAPI. QuickTime, Java. If anybody has CCTV things and they go to a web page to view the video feed from your cameras, most of those require you to download and install a plugin. That plugin is probably NPAPI. Generally speaking, if you've ever had to install software on your computer, which then worked in your web browser, that was probably NPAPI unless you were running on IE. So when you talk about a browser plugin, traditionally that was talking about NPAPI. Now, something that's very important to mention here. Who's heard of a browser extension? Like a Chrome extension? Okay. A browser extension and a browser plugin are not in any way, shape, or form related at all. This is ridiculously confusing and just ridiculous in general, but That is true. And most people don't know that, which causes a lot of confusion because people ask about browser plugins, and then people who actually know enough to answer their questions are like, well, wait, what are you actually talking about? Because it doesn't sound like you're talking about a browser plugin. So browser extensions are very much specific to the browser and have nothing to do with this, although they do unfortunately have to do with some of the other things we'll talk about later. Now, the disadvantages to NPAPI. First, the user must download and install the plugin. This is a really, really big one. In fact, this is almost the number one reason why, at least other than Chrome dropping support is maybe another really big one these days, why using a plugin is not a good user experience, is because the user has to actually download something, run it, install it, etc. That can be a really big barrier to entry for your customers. Also, there are a lot of potential security implications. You are actually running code on their system. So your code runs with the same permissions that the browser does. Generally speaking, although there are a few exceptions, that means that the browser is generally running as a user, or back in the XP days, or maybe even Windows 7 when people turn off UAC entirely, and you're running as an administrator. That means if that browser plugin is malicious, or if it has a security flaw that somebody is able to exploit to make it run arbitrary code, or if it just has bugs in it, it can do frustrating little things like reformat your hard drive, or delete all of your system files, or replace all of your photos in your photo album with cat photos, which is generally not considered to be a good thing. And so you have to be very careful with that. Flash and Java have a really bad history of exploits. Now, Flash, in the last few years, Adobe has actually gotten a lot better. They've been very careful with it, and it's not nearly as bad. Java is still... Has anybody been really annoyed when Java keeps popping up you need to update every few days? That's why. Is because they keep finding security flaws. Now, I think they have other things too, but a lot of times it's because they keep finding security flaws and they need to update it, because has anybody heard of people talk about how if you're just browsing around on the internet, you can end up with viruses if you go to the wrong sites? That's actually not just an urban legend, and it's pretty much Java's fault because of NPAPI plugins and security flaws in Java, where people were able to basically cause a buffer overflow by sending the wrong kind of a packet to the NPAPI plugin, and it installs a rootkit or whatever. So security is a really big deal. Also, Chrome drop support. Firefox has added what they call click-to-play. That font doesn't work, or that color doesn't work well on this screen. But basically what that means is, and that's their response to the security problem, is a plugin by default on Firefox anymore will not load, but it will pop up a thing either where the plugin displays if it's visible, or in the top if it's invisible next to the address bar, where you have to actually say enable this plugin. So NPAPI, a lot of things like that. Now, ActiveX. Who's heard of ActiveX? It's also known as COM, Component Object Model. Has anybody actually done ActiveX development? How do you feel about ActiveX? You're normal. ActiveX, I have, I think, 4 or 5 books that, like, the stack is this tall on ActiveX. Generally speaking, when I have a problem with it, I can't find the answer in those books. Sometimes I can find enough of a hint that then digging through the Microsoft documentation, I can find it. ActiveX is much more broad than just the use in the browser. It also can be used to create, I forget the term, browser helper objects, which can do things like toolbars on IE, so on and so forth. ActiveX, though, is the main technology for doing what we're going to call browser plugins, even though they're technically ActiveX controls, in Internet Explorer. Around Internet Explorer 4, I believe, IE dropped support for NPAPI. They used to have it, but NPAPI has changed a lot since then. And so since then, you've had to use ActiveX, which made browser plugin development in cross-platform way kind of painful. But let's look at the pros and cons. So the pros: it allows native code to be run from the browser. Hey, that's That's familiar. Tight integration with JavaScript, familiar. Now it has excellent JavaScript or drawing support because Microsoft actually uses it, and so they keep updating it, as opposed to NPAPI, where so few people use it, relatively speaking, that they're kind of slow on updating drawing support. It is well known, Flash, Silverlight, QuickTime, Java, just like they all use NPAPI and Firefox and Chrome and such, they all used ActiveX on IE. Common ActiveX controls are used by a lot of different things, and so you can often share the code between them. You may even be able to write an ActiveX control that can either be hosted in your own Windows application or hosted in a web browser or in a number of other ways. So COM, Component Object Model, is intended to basically be extraordinarily interoperable with different types of systems, and in order to do that, they made it complicated beyond belief. Now the cons. The user must download and install the control. Same security implications. You must use COM and ActiveX, which is a royal pain in the neck. And it only works in Internet Explorer. So when you talk to somebody like me that hates Internet Explorer, we have more than just the usual reasons. So those two have been the most traditional, longest running technologies for using C++ in the browser. Let's look at some newer ones. EMScripten. EMScripten is actually an LLVM compiler that compiles C++ to JavaScript. So it compiles C++ so it can run in JavaScript in the browser. How many of you does that terrify? Nobody? Wow, you guys should think more about that one. I guess there was a couple. It's actually kind of interesting, and it's not as bad as it sounds. It might be close, but it's not as bad as it sounds. So let's look at the pros. Big one, no installation needed. It's a JavaScript file. You just load it with a script tag or maybe in a web worker. The C++ compiler actually outputs JavaScript, which can be used in a number of different ways. You can run complex C++ libraries natively in your browser. And we'll see some examples of those in a little bit. It'll probably blow your mind. Both Firefox and Chrome optimize ASM.js compliant code for near-native performance. So somebody came up with this thing called ASM.js, which is basically like a set of functions and stuff that you can call as though running assembly. And the reason that they did this is because you can then take the LLVM compiler, which compiles to their intermediate language, and then there's the last step of the compilation that compiles from that. It links and compiles that intermediate language into the actual machine code. And the way that compilers work, as a lot of you probably know, is you have a lot of that is the same on every platform, but then that last section that targets the compiler or the CPU architecture is actually specific to the machine. Well, ASM.js is a full-featured enough virtual machine that you can actually write compiled byte, the intermediate language you can compile to JavaScript. Now, you look at that and that sounds extraordinarily inefficient because there are native JavaScript calls that are a lot more efficient in a lot of cases than some of these little teeny tiny steps, as anyone who has written assembly would be able to tell you. However, Firefox and Chrome have done something interesting where they can recognize if this block of code is all written for ASM.js. And then they take that and essentially compile it in memory to bytecode that will run, and I'm not sure exactly how the internals on that work, but it's about 2 to 4 times slower than native code, which may kind of sound like a lot, except that when you consider that if they didn't do that, it would be probably a couple orders of magnitude slower, or at least an order of magnitude. So it was really, really interesting because of this, at least in those browsers, you can compile C++ code, and it's actually extremely fast, relatively speaking. And then, if you use some extra JavaScript HTML5 stuff, you can access files, you can access the camera, etc. Now, the cons to EMScripten. You are running in the web page. You're sandboxed. Anything that you can't do, that you can't access with JavaScript, you can't access with something in EMScripten because it's JavaScript. You're limited to the memory available to JavaScript, which has occasionally bitten me. File systems, etc. are virtual, so it does actually implement things like fopen and fread and fwrite, but that's just because it has its own little virtual file system thing in memory. So it's not a real file system, it's just kind of this emulation layer that you can use to make your programs compile a little more easily. So no actual system access. Many uses will require extra JavaScript to perform operations because of that. If you need to do any kind of file operations and need to read a file, you're probably going to have to download the file with Ajax or load the file using the file reader API in order to put it in. Only Firefox and Chrome currently support it really well. Others will perform fairly poorly. Now, I think, but I haven't had time to verify this, that Node.js 0.12 has a late enough version of the V8 JavaScript engine that it will actually, it has the same optimizations. But I don't know how optimized it is because they worked on it for quite some time. And so it's probably faster. It may not be as fast. This is a big one. C++ code isn't usually asynchronous, right? Most of the time when we write C++ code, it's very procedural. Well, what happens in JavaScript if you have a long-running CPU-bound operation that doesn't return? Bad things. Basically, you lock up your browser. If you have in JavaScript, if you run an infinite for loop, the UI will just stop responding until eventually most of the browsers these days, because this is such a problem, will pop up a thing saying, you have a script that's not behaving right. Do you want me to kill it? That's usually not something you want to happen to your code. However, you can use web workers and load the EMScripten in web workers, which is what I've normally done. And that way you have this thread of execution that's designed to be that way, and you post and receive messages from it. So, some ways that I've used it. I told you a little bit about the GradeCam image processing, and I wanted to have a demo on that, but I accidentally I took a bunch of papers out of my backpack last night, and among them were my example forms. So I don't really have an example to show you. I apologize for that. But the GradeCam image processing code is C++, so we compiled it with EMScripten. We loaded it in a web worker. Then we used JavaScript's getUserMedia in conjunction with HTML5 canvas in order to get the image data from the camera, converted it into the byte format that we needed, and pass it in. And suddenly, our users can scan their forms using our processor without actually installing anything. It just pops up, asks them if it can use their camera, and off it goes. It is slower. It takes about 4 times longer to process than native code, but it's completely usable, especially on a newer computer. It does use a lot more CPU, which on a laptop will take the battery down, but anyway. Longer discussion than we want to go into. Another thing we did is we allow them to not only scan from the webcam, you can also upload scanned images. Well, a lot of scanners will scan to TIFF or to PDF. Now with PDF, there's a library called PDF.js, which is actually native JavaScript, and we used that to load the PDFs. But with TIFF, we actually used libtiff. I don't know if anybody has used libtiff. It's a C++ library. It's the reference implementation for TIFF. And we use the file loader HTML5 APIs in order to load that into the browser. We pass it into the EMScripten, compiled libtiff web worker. It reads it, and it sends back the pixel data. So actually some really cool stuff that you can do with that at that point. Now, Google Native Client. Google dropped support for plugins. This is their replacement. Native Client is kind of crazy, actually. It is a native compiler. I don't remember if it's GCC or if it's LLVM, but it actually compiles C++ to native code, or at least to bytecode, because there are 2 different versions, as we'll talk about. But they've done some interesting things, and I watched the presentation, but I don't know the internals well enough to explain it simply. But basically what they've done is they've used a combination of byte alignment and advanced compiler analytics to make sure that there is actually no possible way that you can, even if you did a security exploit, there's no way of creating code that will execute that will jump outside of the size of the image that's generated. Now, if that doesn't make any sense to you, what that basically means is you are completely sandboxed, and even if somebody manages to do a buffer overflow or some other type of code injection attack that can cause it to execute arbitrary CPU code, there's no way of causing it to run anything that isn't inside that compiled image. So even if it runs something else inside that compiled image, it may crash the native client executable, but it's not actually going to be able to access other parts of the system that you're not allowed to access. So it's completely sandboxed, it's completely safe. That's good and that's bad. So let's look at the pros and cons. The pros, there's no installation needed. Because it's trusted, you basically can set up a manifest file that says this is the executable, these are some of the other things you need to know about it, and it downloads it from the web server when it goes to need it. A lot of times these will also be used inside a Chrome extension. And it will just pull it down. So that's cool, no installation needed. It's executed as actual native code, so it's very fast. It should be theoretically about as fast as any other native code. I'm not sure if there might be some minor performance hits. I'm not clear on that. The compiler does the funny things to make sure that bugs can't lead to serious security vulnerabilities. Now, native code is also spelled nacl. Some people pronounce it salt, especially since it uses the PP API, also pronounced pepper API. So salt uses the pepper API, haha. But then in all of the videos I've watched of keynotes from the Google developers, they actually call it nacl. So there's nacl, and then there's pnacl, or pinnacle, which compiles to an intermediate bytecode, which can then be compiled by Chrome on the fly to a platform-specific code. And the advantage to that is that you can use it on a Chromebook, because some Chromebooks are Intel, some of them are ARM. So you've got x86, you've got ARM. In the future, we may have other ones, who knows. But by just creating a Pinnacle binary, which is what I use, then you can target all of those things. And since it's still compiled to the platform, it's basically you distribute the intermediate code version. It compiles it to the platform on the fly. Therefore, you still have the performance things. There's a wide range of drawing, audio, OpenGL, input, and network functionality available. So you can do a lot of different things with them, and every release, they're adding more and more that you can do. Can I have one of those? My throat's drying out.
Absolutely.
Thank you.
You are very welcome, sir.
You're doing a great job. Keep it up. All right.
Thank you.
So the OpenGL does use, I believe it's called OpenGL ES, which is what you would use on a mobile platform. So it's not full OpenGL, but it's pretty good. As long if you're into that sort of thing, which I'm not, you may know more about it than I do. Cons. It only works on Google Chrome. That's the big one. This is my biggest frustration with Google, with what they're doing right now. They're trying to eliminate NPAPI plugins, which I understand, but the way that they're going about doing it, since none of the other browser manufacturers are willing to get on board with any of this, basically it means that those of us who need to support a wide range of platforms have to do more work. Like, yes. Also, you're sandboxed. We talked about this before. That's a good thing because it means there's no security problems, or at least drastically reduced. You still care about stability. But it means that you can't access hardware devices, you can't access file system, you can't call system APIs to find out what networks are connected. There's a whole range of things that people use NPAPI plugins for you can't do with native client. In fact, you pretty much can't access anything that JavaScript can't access. There may be a few minor exceptions to that. You just have a little bit more functionality as far as drawing and multimedia. Yes?
Are there still the same cross-browser restrictions? Like in JavaScript, without doing some configuration options on the browser, you can't connect to
things like cores?
where you got it from?
I haven't looked into that in depth, but I believe it depends on how exactly it's run. So with the Pinnacle plugin, you can run it either from the page or you can run it from an extension. I think in the case of extensions, you can request some additional functionality that way, but I'm not sure exactly the extent. To be safe, I would say probably for the most part it does have the same restrictions, but there may be a few exceptions you'd want to look at it. If you have specific questions and can't find it, send me an email and I'll help you look up some specific information. Go ahead.
So on that note, they have an API that you can use to download URLs, so you can access URLs and use the same core restrictions. There's another API that lets you do raw TCP and UDP networking. That one can only be used in an extension when you have the I forgot what it's called, but the right.
Right, the permission, when you have the permission requested. So there are some networking things that require special permissions in an extension, and you just have to look at what's available in the way that you want to use it. There are actually some ways of communicating from an extension to a web page, so you can do some of that stuff. They're really convoluted. Unfortunately, we'll be talking about that too. So. Also, all communication with JavaScript is asynchronous via a post message API. So you can't do direct function calls. You can send messages back and forth. nacl used to actually have a direct API, like NPAPI and ActiveX do, but they fixed it some time ago. Some of the uses. Basically, it can be used as a faster alternative to EMScripten. So that's one way that we use it. It did exactly the same infrastructure that I just told you with our image processing in EMScripten, except we have a Pinnacle version. So basically we check if we're on Chrome, or well, really we check if Pinnacle is available, you use the Pinnacle one. Otherwise, using the EMScripten one, all of the other code is exactly the same. Now, if I were to go and update that, since I wrote that about a year ago, they have added support for getting camera data, so that might actually be more performant than doing it in JavaScript and then passing it in. So I may actually go at some point and update that to be a little bit more efficient. The final one that we'll talk about is Google native messaging. So I've talked a lot about how these other options, you still don't have access to anything on the system. This is the solution that still gives you access to the system. And the Google engineers are really not excited that they had to provide this, and they get kind of testy in issue reports that you file asking for additional features and say things like, if we had our way, we would not want to ever add more features to this product. We would like it to go away. Fortunately, it hasn't gone away so far, though. So basically, a native messaging is a native background application that it can actually be launched from Chrome. Now, I didn't finish updating this slide. That's awesome. So anyway, these are pros, those are cons. They just weren't labeled because I got distracted by one of the other speakers while I was doing this and apparently didn't finish it. I redid a lot of the slides an hour ago. Anyway, the nice thing, the advantages to native messaging, you aren't sandboxed. You are running a native application. Therefore, you can use system APIs, hardware, arbitrary network protocols. Anything else that you can do with a normal application, you can do in native messaging, which is awesome. As an example, the application could even have its own UI. You could launch a desktop application. As long as it knows how to communicate with native messaging, it could then communicate back to the browser. That's a really cool thing. Disadvantage. Getting tired of seeing that there yet? It only works in Google Chrome. Communication with the browser is all JSON based, which is interesting. The way that it actually works is when it launches the application, it opens standard in and standard out as being the communication thing. And so basically, anytime it sends a message to the native messaging application, it sends it just on, the application reads it using standard CN, for example, or fread to standard in. And when it responds, it just cout, writes with standard out. However, despite the fact that you can write any arbitrary data, and despite the fact that the protocol actually requires you to basically say, here's the length of my message, and then send the message, it still requires it to validate as valid JSON. Now, the reason that that's annoying is because if you ever have to transfer binary data, like, just to take a random example, image data from a camera especially maybe a camera that isn't supported by Get User Media, which seems like somebody I was talking to at one point thought they might want to do at some point and weren't happy with me when I wasn't sure of a really fast way of doing it. Anyway, you basically have to base64 encode it because it has to be something that can be stuck into a JSON document. And base64 is the most efficient way that I know of to do that. Now that's not hugely a problem, but it does have a major performance hit. The user must also install both an application and an extension. So native messaging, you can't actually access native messaging applications from a web page. You can only access it from the background or event portion of a Chrome extension. For those of you who aren't familiar with Chrome extensions, which if you're lucky is all of you, there's background and event, and then there's content scripts which actually have access to the DOM but not to the JavaScript of the page. So they can talk to the DOM, but they can't talk to they can't access any of the script stuff, and it's in a total different execution context. And then what you can do if you need to access this is you can actually use the DOM in order to inject scripts into the page. And then you can use, anybody familiar with cross-window messaging? Well, cross-window messaging is a way of basically communicating between two different pages that are not on the same domain, and therefore the cross-origin policy restricts them from talking normally through direct JavaScript. You can post messages back and forth through the window object, for example, on an iframe. I've had to use that a few times to get around CORS when CORS wasn't necessarily supported on the browser. Well, you can use what we might call same window messaging, because they can both access the window object. They just can't access any of the JavaScript stuff from each other. So they can post messages to themselves and have it go back and forth. So there's actually an architecture that if we have time, I'll tell you about, that basically has the page which talks to the content script, which talks to the background script, which talks to the native message host, which then loads a plugin. Post message, post message, post message, call function, and back. That's what I've spent my last 4 months doing. So if I seem bitter at Chrome, that's why. Anyway, so that's kind of a pain. And of course, we have our security considerations back because we have because we now have native code running again. Also, unlike NPAPI and ActiveX plugins, two things. One is we're still asynchronous because we're posting messages back and forth. Two is that there's no drawing support, at least not in the browser. All right. So I've told you a little bit about, actually, you know what, before we go any further on that, let's take a break from the slides because I know you're all bored. That's not actually where I wanted to go. And let's look at some examples. So I'm running Chrome, and you can run these examples. Let's see. So EMScripten, and I know I put these in there, didn't I? Oh, they're in here. No, where did I put them? I'm going to go a little out of order. So let's look at some EMScripten examples. These are things that people have written in EMScripten. So to remind you, EMScripten is the one where you actually compile C++ into the browser. Quake 3. Anybody heard of Quake 3? I haven't actually tested this, by the way. So we're now loading Quake 3. This is all pure JavaScript. Okay, there is no external thing, which is why it's taking so long. Let's go ahead and, while we're waiting for that, native client examples. It's things that you can do with these. And there's kind of some similar types of things. Wolfenstein 3D. Now you'll notice this is loading a .pexe. So nacl anybody familiar with DOSBox? How many of you are old enough to remember DOS games? Don and I used to play them. A lot of the games that Don and I used to play when we were younger are actually available on DOSBox. And somebody ported DOSBox built DOSBox with nacl. And so you can actually play those in nacl. One of my favorites is Turbo C++. So let's see. Here's Quake.js. Sure. Disable my mouse cursor. Pretty impressive for pure JavaScript, wouldn't you say? Obviously, I'm not really a Quake player, but that's the level of stuff that's actually possible with EMScripten using WebGL. And then you can do a lot of that stuff with nacl as well, although it's not quite as common. I don't even know how to play this one. So you can do a lot of crazy things with those. I've never given this talk before, so I wasn't sure how much different parts would take. Any questions before we go on? And then I want to look at a few pieces of code. All right, so I'm going to make a native client project. Now, there are native client examples, and there are EMScripten examples. I wanted to do our own, so we don't have to worry about the specifics of how they do things. We can worry about the specifics of how I do things instead. I like to use CMake because it simplifies a lot of things for me. But you can go and you can check these out yourself. Now, that's where I put it. One thing to note here is that lost my train of thought. Okay, I have not had time to make these all work on Windows. So if you have a Mac, they will probably just work. If you have Windows, you will probably have to modify them a little bit. Has anybody used CMake before? Okay, so CMake is a build tool for the rest of you that basically creates it can target different building environments. So right now it's actually going to target make using the EMScripten things. So we're going to ensure our HTML5 dependencies, which basically has just downloaded the EMScripten SDK for us. And then we're going to run prepped EMScripten, which is going to run CMake for us. And then we're going to build it. So this is a fairly simple project. Let's go look at the source code so you can get an idea of what's involved here. Let's see, that's probably way too small. Can you guys kind of see that? In the back row, can you see it at all? All right, you've got a bunch of libraries as normal. Down here at the bottom, we have a create module function, which is going to be called by, this is nacl, sorry. We don't want nacl, we want EMScripten, since that's what we're looking at there. You kidding me? I forget to push. I will make sure that this gets pushed. As you can see, I did not have time to make this as clean as I wanted it, and I apologize for that. That is not like me, but GitHub for some reason is not letting me push, even though it's got my keys, and I've never had problems anywhere else, just on this one particular repository. So here is a fairly simple EMScripten demo. As you can see, things that we want to export, we have to do extern C, just like you would with a DLL or something. And then we have test1, which takes a number, returns a uint32. This one It says test buffer. It takes a width, height, a buffer, and returns a string, a constant car pointer. This one is just a get version. It just returns version, which is defined in our CMake file. So basically, this is going to be an example of how you can get a buffer, like an array buffer, and just a couple of very basic functions. Now, the other part to this that you need is the HTML file, and this is how we're going to use it. So I created this wrapper here. Now, module is added to every EMScripten file, binary file has a module. And so CWrap says, okay, wrap this function. Here's the return type, and this is an array of the arguments. So here we're doing the same thing. We're wrapping test buffer, returns a string, takes a number. Now, you'll notice that pixels is actually a, I need to update that too. It technically runs, but this isn't completely correct. I adapted these from the examples that I'm actually using at work to make sure that they would run. So we pass in a width, a height, and pixels, which is going to be an array buffer, which is a buffer of binary data in JavaScript. And we're going to actually allocate memory in the virtual machine of width time height, and then we're going to copy our pixels into the new buffer that we just created. And then we'll pass in width, height, and buff. And buff is passed in as a number because it's actually a pointer, which in JavaScript is just a number, which is the index of where in the memory it's going to be. And let's take a look at, well, we are way running out of time, so I'm going to have to skip some of the stuff I wanted to do. So this is what the compiled output looks like. Wow. And it's too big. It goes so far out, it's too big for Vim to quickly get it. So as you can see, it's not particularly readable. It really looks kind of like a binary file. But that will load in the browser, and it will work. nacl is going to be similar type of a thing. It's a little bit more complicated as far as the source. We have to create, but we've got a lot more power on this. So I'm going to have to kind of leave it as an exercise to you to take a look at the slides, which will be linked from the joined in page as soon as I have a chance to put the link there. But take a look at this. With nacl, you can actually pass complex data structures back and forth. So you can create a dict, you can create an array, you can pass binary data and stuff back and forth. With native messaging, which is the only way of doing native stuff on Chrome currently, there's not an easy way of just doing that yet. However, I'm within a couple of weeks of having FireBreath 2 done, which adds support for native client. Basically, it gives you the same interface, but it automatically converts all calls from a JavaScript wrapper that you can use into JSON, passes it across that convoluted pipeline into a FireBreath plugin where it decodes it and just calls a normal C++ function. And you should really take a look at that if you have a chance, because it's actually really cool stuff. You can, just to give you a quick view, this is how you define functions. It's just like a normal C++ function, except that this is going to be asynchronous when it returns. It's going to give you a promises A+ compliant promise object. And all we have to do is in the JS API object, which is a special type of object in FireBreath, we just register the method, give it those things. It will automatically create the wrappers just using function templates and stuff to do all of the type conversion that's needed to call those functions and do all the type conversion coming back. And FireBreath 2, unlike FireBreath, which is the currently released version, everything is asynchronous going both directions. And so I've actually had to implement promises and deferred objects in C++, which is really interesting. So I apologize that this was not as coherent as I wanted. I hope that it's been at least enough information to give you an idea of what's possible. I was really hoping we could get to more code, but there's just so much on this topic. I could literally talk all afternoon without any preparation on this if we actually wanted to dive into code, but we don't have time for that. So we are out of time. If anybody has questions, feel free to stick around for a couple minutes. We're going into lunch now, but anybody who doesn't have questions, feel free to go. Thank you.